friends, welcome to Igniter Max. At this video, we are going to clear with the concept of the inverse trigonometric function. This concept is completely based on the basics topic like domain, codomain, range, one function, onto function, bijective function, into function. A complete concept is hiding behind the inverse of the trigonometric function. So we'll just scratch the topic from the basic till the end. Okay, for finding the inverse trigonometric function, there is a certain graph that we need to remember. What is the idea behind it? How did it came? What is domain, range at the graph? Okay, how we need to do with it? Each and everything we'll be just doing at this video only. First 5 to 6 minutes we are just clearing the basics. Yes, domain, codomain, range, one onto function. This topic is completely based on the inverse trigonometric function. Yes, what is that logic behind it? Each and everything we'll just do it in the video itself, and stay tuned till the end of the video so that you'll be getting the clear concept of it, and it's 100% guarantee after completing with the video. Inverse trigonometric function, the concept is one of the easiest concept we may think. So stay tuned till the end of the video. First of all, we'll just clear the concept of the domain, codomain, range, pre-image. Yes, so what is this domain called? The domain of a function is a set of all possible inputs. Over here the set A is called as a domain. 1 2 3 4 are the elements are included in the domain. The codomain can possibly come out of the function. Over the set B is called as a codomain. That is, the elements are A, B, C, D are the set of the elements are present on the codomain. The range of the function which actually comes out of the function, okay, in which over here the range is A, B, D. Range is nothing but a set of images, and domain is nothing but a set of a pre-image. Domain is a set of input and the range is a set of output. Range can be a subset of a codomain and the range can be equal to codomain. Definition of a function. A function f from a set A to B, f of A to B, okay, is a relation which associates for each element x in A a unique exactly one element y in B. Condition we need to follow for the function in which all the element of A are related to some of the element in B, in which all the elements are in A should have image in set B. And the second condition, no element of A is related to more than one element of B. So 3 different types of situation is involved at the example 1, example 2 and example 3. We have identified it's a function or not. Okay, later to deeply I have explained in the separate video. Okay, at the description box also you'll be getting the link update, plus at the right side the corner we'll be getting the notification. After the video also we can go through it. Move to the 1 function. Okay, a function f of A to B is said to be 1 if different elements in A have different images in set B. It's called as a 1 nothing but every element in A should have images in set B, then only the function is called as a 1 and the other name is nothing but injective function or 1-to-1 function. Yes, these certain examples are given. Okay, please go through it. Now let's move to the onto function. Okay, in the another word we can say it's a surjective function. According to the ordered pair x comma y, in which x belongs to the A set and y belongs to B set. I hope it's remembered related to the ordered pair. Yes, if every element of y in B has a pre-image x in A, then only the function is called as an onto the surjective function. Okay, over here also we have these certain different types of example. We need to just identify whether it is 1 onto or both. Okay, so let's take the first example. Okay, the A set is given, B set is given. According to the 1 every element in A should have images in set B. Okay, different elements in A have different images in set B. Yes, so at the first example is actually 1. This is onto. According to the onto function, every element in the codomain should have pre-image in the set A in the domain. Yes, is this is having the pre-image? No, absolutely not. The 5 doesn't have the pre-image in set A. function is 1 1 but not onto. Yes, because the element phi has no pre-image in set A. Now let's take the other example. Okay, the set A contains the certain elements, even the set B contains the certain elements. Every element in set A has an image in the set B, then it is called as an 1 1. Yes, it's absolutely right. According to the second example, is 1 1. But onto every element in B should have pre-image in set A. Yes, it's absolutely alright. So the second example is 1 1 and onto 2. To the third example, over here also the set A and set B are given. The certain elements are present over here in which we need to identify whether it is 1 1 onto etc. topics. Okay, now the A element and B element in set A is a image as 1. According to the 1 1, every element, every unique element should have every unique images. Yes, but it's not onto. According to the given definition, it's not onto. Okay, is this onto? Yes, it's absolutely right. It's onto. Every element in the codomain has the pre-image in set A, so it's called as an onto. Let's move to the fourth example. The set A and set B are present. We need to find whether it is 1 1 or onto. So according to the 1 1, every element in set A should have image in set B. Okay, different element of A should have different images in set B. Yes, is this is 1 1? No, it's absolutely not. Okay, is this is onto? Every element in set B should have pre-image in set B. The 1 and 5 is left over, so 1 and 5 doesn't have a pre-image. Absolutely not onto, so the function is neither 1 1 nor onto. The way we have came across the types of the function like 1 1 onto, okay, domain, range, codomain, etc. topics we have covered. But why we have done it? What is the need for it? Okay, for the inverse trigonometric function, because this inverse trigonometric function is completely based on the bijective function, and this bijective function is completely based on the 1 1 and onto function, and this 1 1 and onto are based on the domain, range, etc. topics. So for that purpose we have came across this list of the topics. Before moving to the inverse trigonometric function, we need to be super strong with this basic concept. So let's get started with this inverse trigonometric functions. Inverse trigonometric function are the inverse functions of the trigonometric function. That is nothing but we have the trigonometric function listed over here. So the inverse trigonometric function is nothing but sine inverse of x, cos inverse of x. Inverse of the function, that is nothing but f inverse exists if the function is 1 1 and onto. That is nothing but if the function is bijective, then only f inverse exists. Bijective is nothing but if the function is 1 1 and onto, it's said to be as bijective. The A and B set over here, f of A to B. Yes, we'll just introduce a new term or order pair in which it's called as x comma y, in which x belongs to A and y belongs to B. Yes, it's said to be as 1 1. F of A to B is said to be as 1 1 if every element in A should have image in set B, and it's said to be as onto if every element in set B has a pre-image in set A. Yes, if it is 1 1 and onto, then f inverse exists. According to the diagram mentioned over here, it's able to clear that what is the domain of f and range of f, and the f inverse related part is also clear. Okay, in which range of f, when we are done the f inverse, then it will become as domain of f inverse, and domain of f become as a range of f inverse. First rule for finding the inverse function is it should be a bijective function. That is nothing but it should be a 1 1 and onto function, then only f inverse exists. So in the mathematical term we have represent over here, that is nothing but f of A to B be a 1 1 and onto, and f of x is equal to y, in which x belongs to A, okay, the A set, and y belongs to B, the B set. Yes, the inverse function f inverse B to A is defined as f inverse of y is equal to x if f of x is equal to y. Here at the inverse trigonometric function, the domain has changed into range and range has changed into domain. Yes, we'll actually prove it by the graph of the each and every trigonometric function. Examples for identifying the 1 1 and onto function. So let's take a domain as a natural number and the codomain as even a natural number. That is nothing but f of n to n. Yes, this is 1 1 and onto. every element in set A should have images in set B, then it is called as a 1 1. So every element in set A, that is nothing but natural number, has an image in the set B, that is nothing but natural number, so it is called as a 1 1. So this is on 2. Every element in set B should have pre-image in set A. Yes, even every element of the natural number in set B has a pre-image in set A. Yes, it's 1 1 and on. Let's take another example, f of n2 integers. Yes, so at the set A we'll take a natural number, and at the set B we'll take a list of the integers. Yes, so we need to prove it's a 1 1 and onto function. So it is absolutely 1 1 because every element in set A has a image in set B. But is this onto? No, absolutely not, because every images in set B doesn't have a pre-image in set A. Yes, so the element is not on. Construct the inverse trigonometric tables with the explanation of the graph. So I'll take a graph for the sine for the normal functions with the domain and range, and with inverse also we'll just discuss, and what is the difference between it, how the domain and range changes. Okay, related complete concept we'll just discuss over here. Now let's take an x-axis as domain and the y-axis as range. If we know the value of sine pi by 2, sine pi, sine 3 pi by 2, each and every value is available. Yes, it's just showing over here, just construct it accordingly. We have chosen the period of only 2 pi. Yes, from minus 2 pi to plus 2 pi is showing over here. If we are seeing the graph of it, then the range will lies between minus 1 to 1. Range of the function is the closed interval, that is from minus 1 to 1, and the domain will be taken as a or real value, then the range will be from minus 1 to 1. Okay, now let's move to the inverse of the sine function. Yes, what happens over here at the inverse trigonometric function, first rule is the function should be bijective, that is nothing but it should be 1 1 and onto. Yes, so it should prove the 1 1 and onto function, then only the sine inverse exists. Difference between the inverse trigonometric functions is nothing but over here the domain has changed into range over here. Yes, and over here range has changed into domain. That is the difference between the inverse and the trigonometric function. So even for the graph also changes accordingly. Then over here domain is r. Yes, so in the inverse trigonometric function it will become as a range. So if we are taking as a r, yes, if we are taking as a real number, then accordingly in graph, if we have done with it, then to the inverse trigonometric function it should be 1 1 and onto. In domain it lies between minus 1 to 1, it should be a closed interval. Yes, we have done with it. Taking the range as a r. Yes, so we'll just list it out the range over here. Yes, it's nothing but pi by 2, 3 pi by 2, pi, 2 pi. Okay, even on the minus side, minus pi by 2, minus pi, 3 pi by 2, minus 2 pi. Yes, it's accordingly arranged. It can be 1 1. Every element in A has the image in set B, but it can be 1 onto function. No, it's absolutely not. It can't be onto. Every element in B should have a pre-image in set A, then only it's called as an onto function, the surjetive function. But for the inverse trigonometric function exists, if it is 1 1 and onto, it should be bijective, but over here only 1 1 exists, not onto. So the inverse doesn't exist. At that moment we need to take a range of minus pi by 2, pi by 2. Yes, at that moment the domain can be minus 1 to 1 and it is 1 1 and onto function. Yes, accordingly it's just proving. Just see it over here, it's actually proves. Now not only for minus pi by 2 to pi by 2, in the principal branch as pi by 2 to 3 pi by 2, at that moment also it actually proves the domain is of minus 1 to 1. Yes, we have selected the branch of minus pi by 2, pi by 2. Okay, it's up to us. Even we can select of pi by 2 to 3 pi by 2 also. This is the difference we have seen at the trigonometric functions. Over here we have took as a domain as r, because there is not any certain rule it should be 1 1 or onto function. But at the inverse trigonometric function there is a certain rule, it should be 1 1 and onto. For that purpose we have taken a range of minus pi by 2, pi by 2. Yes. Now the same condition for each and every trigonometric function. We'll just check it for each and everything. So let's take off the cos inverse of x. Okay, let's denote in the graph. Yes, so we are taking the period of a 2 pi. Yes, so that we can understand it. We'll take a domain of -1 to 1 and the range. For the cos inverse x, also the domain lies between -1 to 1 and the range. If we are taking -2 pi to 2 pi, then it can't be onto function. It can be 1 1, but it can't be onto function. At that moment, the inverse doesn't exist. For that purpose, the range we have took over here is 0 to pi. At that moment, the domain becomes -1 to 1. If not, we can take it as pi to 2 pi also. At that moment also -1 to 1. So this is how we need to construct the inverse trigonometry table. So it's actually proved by over here. For the sine inverse and cos inverse, we have seen it is of a closed interval term. Yes, is actually include 0 and pi are included term, not the excluded term. So it's in the closed interval. Seeing in the graph of the tan and tan inverse of x, okay, is just lying in the base of the pi by 2, but it's not touching exactly on the pi by 2. As previously we have seen for sine and cos, is actually on the line of the pi by 2 minus pi by 2. Yes, but at the tan inverse and tan of x, we have seen that not exactly on the certain value. So over here also we have seen of the tan inverse of x, okay, and pi by 2, that is nothing but tan 90, it's nothing but the infinity. For that purpose, we can see it exactly in the graph. Okay, tan pi by 2, okay, minus pi by 2 also the same thing. It's not exactly on the certain value, it is approaching to pi by 2 to minus pi by 2, but it's not exactly the certain value. For that purpose, we have written over here as a open interval. Over sine and cos, it was in the closed interval. And domain will be exactly all the real values. Yes, the cosec, okay, cosecant. Over here we have taken a domain of the real term excluding of -1 to 1. Yes, rest all terms are there on the real values excluding -1 to 1, and the -1 to 1, it's nothing but it's in the open interval. Yes, and the range, if we will see it, it's in the principal branch will be minus pi by 2 excluding -0. Yes, over here we have written over here. Yes, if we are seeing in the graph, we can actually see how does it came, and the darker portion is nothing but the principal branch of the certain trigonometric function. Let's move to the sec. So over here also the same, the domain over here we have took as all the real values excluding of -1 to 1, and the range it's nothing but 0 to pi minus of pi by 2. Okay, why pi by 2? Sec 90 degree, that is nothing but sec pi by 2, it's nothing but infinity. For that purpose we have excluded the pi by 2. Over the cos sec also, okay, we have excluded the 0 because at cos sec 0 it's nothing but infinity. Okay, for that purpose we have excluded it. Okay, and over here cot inverse x, okay, we have taken as a domain as all real values, and the range is nothing but 0 to pi. Okay, this certain graph we have explained separately for each and every trigonometric functions. The certain problem occurs while doing this table. Why the domain is -1 to 1, why the range is minus pi by 2 pi by 2 over here. I hope it's too clear. If any queries, then don't forget to comment. I've came into the end of the video by clearing lots of the concept of the domain, codomain, range, the inverse trigonometric function, a complete table we have derived. Later to graph concept we have gone through it, and if any queries, then don't forget to comment in the comment box. If it's so helpful, then do like, share and subscribe.